So in the previous session, we have discussed how to build the basic visualizations in Tableau. I hope you have practiced those tasks. So let me move on to the next scenario. Scenario 6. Working with multiple dimensions in one single worksheet. So how to work with the multiple dimensions? So in the previous session, just you have taken only one dimension and only one measure. Okay, in all the previous session tasks, just we have taken only one dimension and one measure, and it is very straightforward to build that visualization. So now how to work with the multiple dimensions in Tableau? We have the multiple dimensions, then how to work with it. So how to work with the multiple dimensions means we are having two ways. To work with the multiple dimensions, we are having two ways. Number one, nested table, and next number two, small multiples. To work with the multiple dimensions, we are having two ways. Number one, nested table, and next number two, small multiple. So let's start with the first one, nested table. So what is a nested table? So what is table? In Tableau, table is nothing but the visualization. In Tableau, table is nothing but the visualization. So in Tableau, how to build the visualization? Just we have to drag and drop the fields into. Just we have to drag and drop the fields into rows and columns. So in Tableau, table is a collection of fields in the row shelf and the column shelf. Okay, yes, in Tableau, table is a collection of fields in the row shelf and the column shelf. So, okay, so what is a nested table means? So, what's the meaning of nesting? If you place one dimension inside the other dimension in the visualization, okay, if I place one dimension inside the other dimension, let's say I'm having one dimension. So I'm having one dimension, dimension 1. Okay, on that dimension, if I place other dimension, on that dimension, if I place the other dimension, on that dimension, if I place the other dimension, then such a kind of visualization is known as nested table. Okay, so if I place one dimension inside the other dimension, then such a kind of visualization is known as the nested table. So let's build few charts, and it will be very clear. So I'm taking the first task 1. In a task 1, I would like to show year wise, quarter wise, total sales. So I would like to get year wise. So inside the year we have to place the quarter. So year wise, quarter wise, total sales. So how to check this? So I'm clearing my visualization from the toolbar. So how to get year? Just drag the order date and drop into rows. So here Tableau will take all the years, and here I'm taking one more dimension called as quarter. So again just drag the order date. So and drop it into the rows. So as first Tableau will show the highest date part. So after the year, what is the next level? The next level is quarter. So obviously Tableau will show us the next level, that is quarter. So here we got the year, and inside the year what I have placed the quarter. So within one dimension I have placed the other dimension, and next for this dimension I would like to show the measure values. So just sales. Just drag the sales and drop it into columns. Okay, just drag the sales and drop it into columns. So how to show the values? If you want to show the values, we have to click on ABC. Okay, we have to click on ABC. So after placing the year and quarter here Tableau is showing us some small parts, right? So for year, Tableau is showing differently within one box. It is known as one part of the visualization. And also for 2011 here tableau is showing us all the values in one box. It is also known as one part of the visualization. So here each and every part is known as a pane. Okay, the term is pane. Okay, each and every part is known as a pane. So this 2011 is one pane, this 2012 is second pane. Okay, so 2011 is second pane, 2012 is the third pane, and 2013 is the fourth pane. So what is a table means? Table is a collection of multiple panes. And what a pane contains means, in the pane here we are seeing four values, right? For each and every quarter, here we are seeing the sales values. So each and every value is nothing but a cell. Okay, each and every value is nothing but a cell. So in each and every pane, I don't want to show all the values. In each and every pane, I don't want to show all the values. Only I would like to show the minimum value and the maximum value. In every year, what is the minimum value, okay, and what is the maximum value for all the quarters. I would like to show only minimum and the maximum. So how to show only the minimum and the maximum values? So how to show means, so here how we got the values, with the help of the label we got the values. So once click on the label, if I click on the label, okay, if I click on the label here, we're having an option called as marks to label. In marks to label, by default it is showing us all. All means all the values. If you want to show the values only for the min and max, so in marks to label here we got one more option called as min and max. So just click on min and max. If I click on min and max, Tableau is showing us only the minimum value and the maximum value for every year, because we are showing only the minimum and the maximum, and we are showing us the minimum and maximum for what is scope. We are showing us the scope for pane. So what is pane? Each and every year, okay, each and every part is known as a pane. If I click on table, if I click on table, then Tableau will go, okay, then Tableau will show us the minimum and maximum for the entire visualization. So the collection of multiple panes is known as a table. And if I click on cell, then Tableau going to show us what. So what's the meaning of cell? Each and every value is known as what cell. So if we take at each and every value level means each and every value will act as, okay. So for the value itself, the value would be the minimum and the value would be the maximum. So this cell, it won't work here. So I'm taking only the pane. So here we got the first visualization for the nested table. So here we have placed only one dimension inside the other dimension, right? So it is the example for first level nesting. So let me add a title. So it is the example for one level or the first level nesting. So let's build one more task. So it is a task 1. Okay, so next in my task 2, I would like to show department wise, category wise, region wise, total order quantity. Department wise, category wise, region wise, total order quantity. So here we are having, okay, here we are having 3 dimensions. So we have 3 dimensions, then how to build the visualization. So to build the nested table, we have one more way. So the other way, just identify our innermost dimension and identify the outermost dimensions. So here, what we have to place here, we have to place department as the order dimension. Inside the department, we have to take what category, and inside the category, we have to take what region. So here, which is the outermost dimension? The outermost dimension is department, and the inner dimensions are category and the region. Inner dimensions are category and the region. So now if you talk about some rules, even we're having some rules to build the nested table. The rules are the rule number one is first identify the inner and outer dimensions. Identify the inner and outer dimensions. And the rule number two is place inner dimensions. Place all inner dimensions inside the outer dimension. So for the outer dimension, just place all the inner dimensions inside. Okay. So now these two are the rules to build what nested table. So if you have more than two dimensions, it is very useful to use this, to apply these rules. So these are my inner dimensions and the outer dimensions. So here we have to first drag the outer dimension, which is department. So just drag the department from the product. So drag department. So department wise. Next we have to show the category wise. Just drag the category and drop it into rows. So department wise, category wise, and the region wise we have one more dimension called as region. So department wise, category wise, region wise. So here we got department, category, region. So what we have to show here? We have to show the total order quantity. So I would like to show in the form of text table. So if we drag and drop any dimension and measure into columns and rows, by default Tableau going to show us. By default Tableau going to show us some visualization, right? Like either line chart or bar chart or something like that. But now here I would like to build the visualization or the table in the form of text. So this complete visualization is nothing but the table, right? So instead of showing any visualization table, I would like to show the text table. So it means what I would like to show only the values without any visualization. So how to show the text table? So how to show the text table means just drag your required measure, and drop it into label of the marks card. Here we're having the label. So just drag your required measure and drop it into label of the marks card. If I drag it and drop it into label of the marks card, here Tableau is showing us what? Here Tableau is showing us only the textual information for our dimensions. Here Tableau is showing us the textual information for all our dimensions. So in this way we can able to build the text tables. So text table means just showing only the values without taking any visualization. So it is the example for two-level nesting. It is the example for the two-level nesting because here I have placed two dimensions inside my outermost dimension. Okay, so two-level nesting. Next, let's perform three-level nesting. In my next task, I would like to show year-wise, quarter-wise, month-wise, day-wise, average discounts. Day-wise average discounts in the form of text. So here I would like to show year-wise, quarter-wise, month-wise, day-wise, average discounts in the form of text. So here first we have to identify the inner dimension and the outer dimension. So here the inner dimensions are quarter, month and day, and the outer dimension is year. Okay, here the outer dimension is year and the inner dimensions are quarter, month and the day. So now let's try to build this chart. So let's take the year, next just drag it and drop it here, next quarter, next again drag the order date and drop it here, next is month, and again drag it and drop it here, next tableau going to take what? Day. Here we're having year, quarter, month and the day. We have to show average discounts. So how to get the average discounts? Just drag the discount and drop it into text. So the discount is being the non-additive measure, Tableau will take what? Tableau will take the default aggregation as average. So it is a task 3. So here I have placed 3 dimensions inside the outer dimension. So it is the example for 3-level nesting. It is the example for 3-level
Well, it's not required to drop it on column at all. Just we need to drop it on text itself.
No, actually, if you drag it and drop it, the measure into the columns, it is going to build some visualization, right? Like line chart or bar chart like this.
Okay, we should not put both in columns and also in label. We should put only in labels. You mean to say?
Exactly, because if you take it in columns, it is going to build the visualization. That's when Tableau how to get the visualization with the help of DL. So it means what the descriptive language will take the fields on the rows and columns and it is going to plot them in the form of the coordinate system, like in the form of line or in the form of bar like this. So just here we're passing the required coordinates on the x-axis and the y-axis. So if you place the columns, if you place any measure into the columns, means we are giving the descriptive language some x-axis. So now that's why it is plotting the visualization. So after plotting the visualization, if you place the discount into the label, means just it is going to show us the values. That's it. But here I don't want any visualization. Just I want only the values. So if I remove the discount from the column, then we are eliminating one axis here. Okay, here we are not having the x-axis. So if we don't have the x-axis or y-axis, then how to plot the values? We cannot plot the values, right? In the form of visualization. So that's why here Tableau is showing us only the values associated with our dimensions.
Okay, in the previous example, you were just showing us how to. You did not press the control. You just dragged it and put it in the text field. Okay.
Yeah, if I hold the control, means it will take the copy of the field, right?
Yeah, got it. Yeah, thank you.
Yeah. So let me rename the sheet as task 3. So if I select any value in the tooltip here, Tableau is showing us. In the tooltip here, Tableau is showing us the complete information of my visualization. So from where I got this information, means here we have the tooltip. Okay. If I click on the tooltip here, in the tooltip we can able to see the complete information. Okay. So even we can modify this tooltips also. About the tooltips, we'll discuss in the coming sessions. So here it is an example for the 3-level nesting, right? So in Tableau, one important certification question is what is the maximum level of nesting possible in Tableau? Okay, what is the maximum level of nesting possible in Tableau? So the maximum level of nesting possible in Tableau is 15. Why 15? Why 15 means in the row shelf or in the column shelf. Okay, see one more thing is not only in the rows, we can place these dimensions in the row shelf also. So how to place? Just swap them. If I swap them now, Tableau going to show us the information in the form of in the horizontal way. Whereas if I place my fields into the rows, Tableau will show us information in the vertical way. Okay. So if the dimension is having the more values, one shortcut is just place all the dimensions in the rows, because if I place it in the rows, we can see the values from top to bottom. So if we want to analyze the data from top to bottom, it is somewhat easier than if we want to analyze from left to right. If we want to analyze from left to right, it is somewhat difficult to analyze. Whereas if we place it in the rows, means we can able to analyze from top to bottom, it is somewhat easier. Okay. So Okay, here what is the maximum level of nesting possible? The maximum level of nesting possible is 16. Why 16? In the row shelf or in the column shelf, the maximum number of dimensions we can place is 16. In the row shelf or the column shelf, the maximum number of dimensions we can place is 16. So we cannot place more than 16 dimensions by default. So here how many dimensions I'm having? Here I'm having 4 dimensions. If I have 4 dimensions, we go to nesting level 3. It means how to identify the nesting level means the formula is n minus 1, whereas n indicates the number of dimensions. So how to identify the how to identify the nesting level means the formula is n minus 1, where n indicates the number of dimensions we are having. So in this case, how many dimensions we are having? In this case, we are having 4 dimensions. So 4 minus 1, 3. So the nesting level is what? 3. So why minus 1 means because the outer dimension, outer dimension, it won't add any nesting level. So if you take outer and the first inner, nesting level is 1. If you take the outer and the second inner dimension, the nesting level is 2. If you take the outer and the innermost dimension, the nesting level is 3. So the maximum number of nesting level possible in Tableau is 15. So is it possible to increase this nesting level or not? Yes, it is possible to increase the nesting level. So how we can increase this nesting level? So how internally this workbook will be stored means, so in which format the work will be saved is in the format of the workbook. So if I click on the save, Tableau going to save this work in the workbooks folder of the Tableau repository. Right? Let's say for example I'm saving scenario 6. Okay, nested tables. So I'm saving it in my Tableau repository. So once if you go to the Tableau repository and if you go to the documents and if you go to that workbooks location, now if you right click on it, so scenario 6. So as I have told, this workbook will be stored internally in the format of XML. Just simply right click on the workbook. If you right click on the workbook, if you open with the notepad, you can able to see the internal structure of the workbook. Okay, it is the internal structure of the workbook. So here in this workbook, we used to have one tag known as the column limit and the row limit. We can able to change that column limit and row limit to our required value. Okay, but it is not recommended. It is not recommended to change the existing values because the level 15 means the level 15 means it is very much deeper. So if we increase more levels, then even we cannot perform the effective analysis. And also here one more thing is, now here I am building the visualization in 8.3, right? Here I am building the visualization in 8.3. In your machine, let's say you are having 9.2. Okay, I have done in 8.3 and in our machine you are having 9.2. So is it possible to open the workbooks built on 8.3 and 9.2 or not? Yes, we can able to. Whatever the workbooks we have built on the lower versions, we can open on the higher versions. Okay, it won't be any difficulty. Whereas whatever the workbooks if you built on the 9.2, if you try to open in the 8.3, then it is not possible. Okay, then it is not possible to open the workbooks which we have built on 9.2 in 8.3 because 9.2 is the latest version and 8.3 is the prior version we cannot open. So even though if you want to open the workbooks which we have built on 9.2 in 8.3 means it is also possible. So here we have to just change the in the XML here initially we are having one tag known as version. Okay, here I have saved the workbook on which version 8.3. If I try to open in 8.1 it won't open because 8.1 is the the previous version. So let me open 8.1. So So how to open? Just click on file, click on open, click on file, click on open. So now I'm having it in my Tableau repository, workbooks. So scenario 6. Just hit open. See here. So it is giving us some errors. Just click on show details. See, the file was created by the newer version of Tableau. It is going to give us this error. Okay. So we cannot open in the lower versions. So if we want to open in the lower versions, then how to open means just we have to change the version to the required version. So now if I replace this version 8.3, just simply copy that version 8.3 and just replace with the required version 8.1. Now we replace all, and if you save it, now we can able to open even in the 8.1 also. Okay, it is possible to open.
How to open a TWX file, edit a TWX file? TWB, I saw you open in Notepad, but I was not able to open a TWBX.
That's a good question. So basically, like in Tableau, the workbook we can save in two formats: in the format of workbook and in the format of packaged workbook. So what is a packaged workbook means? Packaged workbook is nothing but a zip file. Okay, it is going to zip the data source and the visualizations in a single packaged file. We cannot open the packaged workbook directly in the form of XML. So how to differentiate the normal workbook and the packaged workbook is, for the packaged workbook the extension is .twbx. So how to save it in the packaged workbook format is, just click on file, just go to save as. So we can able to save our work in the form of .twb, just Tableau workbook, and also in the form of .twbx, which is the packaged workbook. This packaged workbook is nothing but a zip file. Okay, so one compressed file. So this packaged workbook, it is going to pack the packaged workbook. It is going to pack the visualizations and the data source in one single file. So here I am saving it in the form of single package, in the form of single packet file. So now it got saved. Now it got saved into the Tableau repository. It is .twb. So .twb means Tableau workbook, and .twbx means Tableau packaged workbook. So the Tableau packaged workbook will be indicated with this line, okay, this yellow line. So if you try to open the packaged workbook, okay, in the XML, it will show us the encrypted values. So you cannot directly open the packaged workbook. You cannot directly open the packaged workbook in the form of XML. So here what we can able to do here is, we can simply copy that packaged workbook. We can simply copy that packaged workbook. So just for showing you, I'm taking, okay. Just I'm placing it in my desktop. You can do it from our desktop or from your repository also. Just paste here. Now first we have to unpack, because the package workbook .twbx is the combination of .twb plus local data files. So we can open only the Tableau workbook in the XML format. We cannot open the Tableau packaged workbook in the XML format. So first we have to unpack this. If we unpack this, then we can able to see, okay, .twb and local data files separately. So how to unpack this? Just simply right click on this. If you right click on it, here we are having an option called unpackage. Just click on unpackage. Just click on unpackage. So just hit OK. Okay, how to see it? After unpacking, here we got what? Here we got the .twb and the data files. Okay, so here it is a data source we are having it, superstore extract. So now right click on it, go to open the notepad. So here now we got So directly the bottom line is you people cannot open the packaged workbook or .twbx in the format of the in the notepad. What we have to do is just we have to unpack it. So how to unpack? Just simply right click on that packaged workbook or .twbx file and click on unpackage. So now here I am deleting these things. So it's
And to
clear.
unpack that, do we need to have the 9.2 version in our system?
No, it's not required. Why? I mean, if you want to unpack or what? If you want to unpack, you need the version. Because if you save it in the 9.2 means you need 9.2 to unpack that workbook.
Okay. In the remote desktop which was given to us, 9.2 was not there, so unpacking was not working. You just throwing an error that it cannot unpack.
So like which version you are having currently there? 9.1 or 9.0?
9.0 only we are having. The file which I got from you was having a 9.2 version, I think. It's a 9.2 package. So
Yeah. So one thing you can do is like you can install 9.2 in your local and you can unpack, or one thing what I can do is I can save it in the form of 9.0 and I could give it to you.
yeah, that would be helpful, I think. Yeah, thank you.
Yeah. So it's all about the nested table. So the maximum level of nesting is 15. So then here as we can place only the 16 dimensions in the row shelf or the column shelf, then what about the limitation for measures? How many maximum measures we can place? For the measures we are not having any limitation. We can place n number of measures. Okay, for the measures we are not having any limitation. We can place n number of measures, but only for the dimensions we can place 16. Okay, the maximum count of dimensions we can place is 16, and for the measures it is n. So the second way to work with so I hope it's clear. I hope it's clear, right, guys? So do you have any questions on this nested table? Any questions on the nested table? So till now, any questions? Okay, I hope it's clear. So let me move into the next concept, small multiples. So the second way to work with the multiple dimensions is small multiples. Number 2, small multiples. So how to work with the small multiples in Tableau, or what is a small multiple? Okay, the small multiples are the extensions to the nested table. Okay, small multiples are the extensions to the nested table. Small multiples are nothing but just dividing or breaking down the visualization, just dividing or breaking down the visualizations into small parts, okay, into small multiple parts. So I will explain with a task. Here what I would like to show here is I would like to show year wise total sales in every quarter. Okay, here I would like to show year-wise total sales in every quarter. In every quarter, here you would like to show the year-wise total sales. So how to achieve this? So first, in BI, okay, understanding the question is very important. So if you don't understand the question properly, one shortcut is just divide that question into two parts. Okay, just divide that question into two parts. So this question is having two parts. The first part is year-wise total sales. So till now we can build. So just we can drag year into rows or columns, and we can drag sales into rows or columns, and we can able to get the visualization. So here it is the first part. The second part of the question is in every quarter we want. It means what? Like if I drag and drop the year like 2010, 2011, 2012. Tableau going to show us the values like this, all the year values, and then it is going to show us the sales values like this. If you have the sales values, Tableau going to show the sales values with the help of some line like this. But here we want the sales values for every quarter. It means what? In Q1, what is the sale value? And Q2, what is sale value? So here we have to show the sales values specifically for every year. Okay, specifically for every quarter and for every year. So for every quarter, we have to show the values specifically or separately. So how to achieve that? So how to achieve that means just first let's build the first part, year-wise sales. So I'm taking year and I'm taking sales. Here Tableau is giving us the year-wise sales. So here we want to get the year-wise sales in every quarter. So how to get the year-wise sales in every quarter means, so the logic is just simply multiply the required dimension with the measure. Okay, just simply multiply the required dimension with the measure as if we want in every quarter. So just drag the quarter and drop it into the shelf where we are having the measure. Here I am having the measure in the row shelf. So just drag the quarter and drop it along with the measure. So here what we want the quarter. So how to change the year to quarter means just simply right click on it and click on quarter. So now here we got year wise. Okay, now here we got the sales in every quarter. You see here in the bottom we're having the year. Okay, in the bottom here we're having the year, or in the rows here we're having the year, and here we're having the quarter. So here we are showing the quarter values separately. So let me show you this again. Okay, let me show you this again. So first I am taking year into my rows and sales into my columns. Here I want specifically the sales in every quarter. So how to get the sales specifically in every quarter means just we have to place the quarter along with our measure. So it's nothing but just multiplying the dimension with the measure, because what the measure contains numbers and what the dimension contains textual value. So just here we are multiplying the dimension with the measure. So here just take the required dimension, which is quarter. So now here we got year wise, quarter wise total sales here we are having. Okay. So here two things have happened. So before dragging the quarter, here we had the visualization in one way, and after dragging the quarter, here few changes has happened. So let's try to identify the changes. So what is the first change? So just observe carefully here. If I drag the order date and if I drop it into the columns, here I am trying to place to the right of the measure. Here I am trying to place to the right side of the measure, but see here where Tableau is placing the dimension. Okay, see here where Tableau is placing the dimension. Even though if I try to place the dimension to the right of the measure, here Tableau automatically placing the dimension to the left of the measure. Let me show you again. Here I am trying to place the dimension to the left side of, here I am trying to place the dimension to the right side of the measure, but here Tableau is placing this dimension automatically to its left. Why? What is the reason? Okay, already we have seen the reason. The reason is always okay, the dimension will act as what the parent and the measure will act as what the child, because without the dimension or without the master, the transaction cannot exist. So we cannot place the dimensions as the dependent fields or as the inner fields to the measures. Always the dimensions, okay, always the dimensions will act as the outer fields. So now how to get the, here it is the one change. The first change is what? It is not possible to place any dimension to the right of the measure. Even though if you try to place, Tableau will place the dimension to its left. It is the first change. Okay, the second change is here. Okay, the second change is, let me select the quarter. So before placing the quarter, here how many lines we are having? before placing the quarter, okay, just we had only one line. Before placing the quarter, just we had only one line. And after placing the quarter, that line, again that line has been divided into 4 lines. Because for every quarter here we are showing the information. Okay, here before placing this quarter, just we had only one single line, and after placing the quarter, okay, this line has been divided into 4 parts, because we are showing at the level of quarter, here we are showing at the level of quarter, so Tableau has divided that line into 4 small parts. So these kind of visualizations are known as the small multiple charts. So what are small multiple charts means? Small multiple charts is nothing but breaking down one visualization into small parts, based on the small multiple dimension. Here quarter will act as the small multiple dimension, because for every value of the quarter here we are having one part. Okay, we are having one small part. So here more importantly we are showing information for every quarter. So to build the small multiple chart, again we are having a few rules. The few rules, the rule number 1 is identify normal dimensions and the small multiple dimension. Next, the rule number 2 is place the small multiple dimension along with the measures. Okay, just place the small multiple dimensions along with the measures. Okay, along with the measures, just place the small multiple dimensions. So the rule number 1 is we have to identify the normal dimensions and the small multiple dimensions, and we have to place the small multiple dimension along with the measure. So here the question is how to identify the small multiple dimension. So in the question, so that's why in the BI understand the question is very, very important. So if you see, okay, if you see the words like in every quarter, in each and every year, if you see those adjectives like every or each, then okay, the next dimension will act as what? The next dimension will act as the small multiple dimension. So let's try to identify here which is the normal dimension. Here is the normal dimension, ND is the here, and which is the small multiple dimension. The small multiple dimension is quarter. The small multiple dimension is quarter. So how to identify the small multiple dimension? In the question, if you get the things like in every quarter or in every year or in every month, okay, or in each month, in each quarter, in each category, then the each fields or every fields, okay, the adjective fields comes under what? Small multiples. So here we got the small multiple. Okay, it is a small multiple task 1. So let's try to build next task. In my next task I would like to show, I'm taking the same task here. I'm taking the same task, the task which I have discussed here. So I'm taking the department wise, category wise, total order quantity in the form of text table for every region or for each region. Okay, for every region or for each region. So how to build this? Department wise, category wise, total order quantity in the form of text table for every or each region. So here, what is step 1? The step 1 is we have to identify the normal dimensions and the small multiple dimensions. So here we have two normal dimensions. So what are the two normal dimensions? Department and category are the two normal dimensions. And here we have one small multiple dimension. So here what is small multiple dimension? Region is the small multiple dimension. Here region is the small multiple dimension. So here I'm getting a new sheet. So let's try to build the first thing. So first just break down the question into two parts. The first part of the question is what? Department wise, category wise, total order quantity. So department wise, category wise means what? We have to place the category inside the department. So till now it is a nested table. So this question is a combination of nested table plus small multiples. So just drag the department. So department wise, category wise, okay, total order quantity in the form of text. So how to get the text? Drag the order quantity and drop it into text. So here we got department wise, category wise, total order quantity in every, okay, in every region. So how to get it in every region? So how to get it in every region means just drag the region and drop it into columns. See here, for every region here, what Tableau is showing us? For every region here, Tableau is showing us the values. So before placing the region here we have only single consolidated values for the department and the category. And after placing the region, we got values in 5 rows. For every region here, what we got? Here we got the values. Even we can able to build the text tables, okay, for the small multiples also. So it is small multiple task 2. Let's build one more task. So in my next task, I would like to show department wise, year wise, average profits in every continent and ship mode. Okay, here in our task 3, I would like to show the department wise, year wise, average profits in every continent and in every ship mode. Here we have two normal dimensions. They are department and year, and we have two small multiple dimensions. The two small multiple dimensions are continent and ship mode. Okay, the two small multiple dimensions are continent and the ship mode. So how to build this? Just drag the department. And drop it into rows. Okay, next drag the department wise. Here what we have to show department wise, year wise, average profits. So just department year, just drag the order data and drop it into rows. So department wise, year wise, average profits. I'm taking the profits into my columns. How to get average? Right click and select the aggregation as average. Okay, select the aggregation as average. So department wise, year wise, average profits. So average profits in every continent and in every ship mode. So now we have to break down this visualization based on the continent and also based on the ship mode. So how to break down with the small multiple dimensions. So first drag the small multiple dimensions and drop it into columns. So here we have broke down at the continent level, and here we have to add one more thing, that is ship mode. So just drag the ship mode and place it next to the continent. So here we have continent wise, ship mode wise, average profits, sorry, department wise, year wise, average profits in every continent and the ship mode. So in this way we can break down the visualization into n number of parts with the help of the small multiple dimensions. So here each and every part is known as what? Here each and every part is known as a pane. Okay, each and every part is known as a pane. So how many panes we can build in one visualization? So what is the maximum pane supportivity in Tableau? One important certification question is, okay, what is the maximum number of panes can Tableau support in one visualization? So the maximum number of panes here the Tableau can support is, within one worksheet Tableau can support up to 1 million panes. Okay, Tableau can support up to 1 million panes. So if we want to create beyond 1 million means just we have to do some filtering. Okay, we have to perform some filtering and we can restrict the number of pins. So on a whole maximum we can create up to 1 million pins. So in the certification, one more question is, they'll give the visualization like this. Okay, they'll give you the visualization like this and they want you to identify number of panes we are having. Here how many panes we are having? Here how many panes we are having? Okay, so how many panes we are having? Like if you want to know how many panes we are having, we have to count each and every pane manually. So if you have say like 10,000 panes and if you are counting the 10,000 panes manually means it will kill a lot of your time, because in the certification, okay, managing in the certification exams, managing the time is very, very important. Okay, so we cannot count this number of panes manually. So how to count means we're having a shortcut. The shortcut is number of values in the normal or the nested table dimensions, in the normal or the nested table dimensions, except innermost dimension, dimension into number of measures into number of values in the small multiple dimensions. So if you're working with multiple dimensions, always we can get these two types of charts only, either nested tables or the small multiples. So how to identify the number of panes in the visualization is number of values in the normal or the nested table dimensions except the innermost dimension into number of measures into number of values in the small multiple dimensions. Okay, I will explain this. So here in the nested table dimension, okay, here in the nested table we have two dimensions. They are department and the year. So department and the year are what they are the nested table dimensions. So here how many values we are having in the nested table dimensions? The logic is number of values in the nested table dimension except innermost dimension. So first we have to make sure how many values we are having in the nested tables. So in the nested tables here we have two dimensions. So here year is what? Year is the innermost. Here year is the innermost. So just ignore the innermost dimension and take the other dimension. What is the other dimension? Department. In department here how many values we are having? 3. The department just we are having the 3 values. So 3 into how many measures we are having? Only one measure, that is average profit. Okay, yes. So number of values in the nested table dimension except innermost. So here is the innermost, just ignore that and just take the values of the department and into number of values in the small multiple dimensions. It means what? Number of values in the continent. So we have 6 values in the continent into number of values in the ship mode. Okay, into number of values in the ship mode. So let's see how many values we are having in ship mode. Just drag the ship mode, drag it and drop it into the rows. So how many we are having? 3. Okay, so total we are having 3 ship modes. So 3 into 1 into 6 into 3. So it is equivalent to 36. So 6 into 6. Okay, it's not 6 into 6, like 3 into 1, 3 into 6, 18 into 3, 54. So totally we're having, total here we are having 54 panes here. If you count, we'll get the count as 54, okay? So in that way, even we can able to identify the complex number of panes also. So the last task for the day, now let's say I'm taking my task for, I'm taking year wise, quarter wise, month wise, shipping costs in every ship mode, and order priority. So here what are the normal dimensions? Year, quarter and month. Year, quarter and month are the normal dimensions, and ship mode and the order priority are the small multiple dimensions. So just take what? Year. Just take year, quarter, and month. Okay, year wise, quarter wise, month wise. Here what we want to show? We want to show shipping cost in every ship mode and order priority. Shipping cost, drag it. In every ship mode means what? Every dimension comes into what? Small multiple. So how to get small multiple? You have to multiply the dimension with the measure. In every ship mode, drag ship mode and drop it into columns. In every ship mode and also order priority. Just drag the order priority. So here, how many panes we are having? How to know the number of panes we are having? If we want to count the number of panes we are having, the logic is same. Number of values, the normal dimensions or the nested table dimensions except the innermost dimension. So here which is the innermost? Month is the innermost. Just ignore the month. Okay, just ignore the month. So here how many years we are having? 4 years. Here we are having 4 years. So 4 into how many quarters we are having? 4 quarters into how many measures? We are having 1 measure, that is shipping cost, into how many ship modes we are having? We are having 3 ship modes, into how many order priorities we are having? How many order priorities we are having? Here we are having 5 order priorities. So 4 into 4 into 1 into 3 into 5. So sorry, not 4, it's 5. So here what is the count here? So 4 into 4, 16. 16 into 1, 16. 16 into 3, 48. So 48 into 5, 240. So here we are having 240 panes. If you count, we will get the number of panes as 240. So now if we take here the region also now. Here how many panes we are having? So 4 into 4 into 12. Okay, so 4 into 4, 16. So 16 into 12, 192. 192 into, okay, 192 into 3, like 576. 576 into 5, I guess I'm close to 2500 panes. Sorry, close to 3000 panes. Okay, here we're having close to 3000 panes. In that way, we can able to calculate. So this logic will help you for writing the certification exam. So it's all about working with the multiple dimensions in tabulators. It's all about scenario 6. So any questions on this? Any questions on this?
Oh, this innermost thing is there, right? Generally, do we get assignments like this in the real time? That means, is it easy to analyze this innermost wise? Because if you see, it's showing a huge number of panes, right?
Yes,
so
yes.
how will we analyze this? In what way Can you give an example?
Like if you ask here, the innermost is a region, right? So it means what here we are seeing the information at the level of region. So it depends on how much level of detail you want to see. Okay, it's nothing but the granularity level. The level detail information of our measure is known as the granularity level. It depends on the granularity level of your project. So if you want to see the at the level of the day means, then obviously here you have to take the day also here, right? Yes, in the real time you will get these kind of requirements also.
If you say 10,000 panes are created or 1 million panes is the maximum you said, right?
Yes.
But how will we analyze? Is it for recording purpose or just to keep as a record what is this, or can somebody look into it and analyze actually?
I mean, the clients, they don't know like how many panes we're having. Just need to make sure whether the values are correct or not. Yes. Here first we have to make sure whether we got all the values or not. Here I have taken total 6 dimensions, right? Here how we can know here we got the values for all the dimensions or not. So here how Tableau is placing all the values in the form of one pane, right? Separately here Tableau is placing the values in the form of one box. This box is nothing but one pane. So here we have to make sure whether we got all the panes or not. If we got the less number of panes means our visualization is wrong.
Okay.
Here we have to show the values for all the dimensions which are part of the visualization.
Okay. Yeah. Thank you.
Yeah. Okay, so any other questions?
So first of all, I have a doubt.
Yep.